Python's challenges can become your greatest AI advantage, but only if you play it smart. Here's a hard truth many in the enterprise world won't say out loud. Python itself is simple. It's everything surrounding it that trips people up. Most developers can get comfortable reading and writing Python within a couple of weeks. Yet what really throws them, and in turn disrupts your project timelines, is the massive ecosystem orbiting the language. This includes things like setting up projects, managing packages and dependencies, handling imports, testing rigorously, and crucially, dealing with the data infrastructure where Python proves its true value. This was crystal clear in the discussion sparked by Python expert Matt Harrison when he asked, "What's your toughest hurdle learning Python?" And the answers didn't mention syntax once. They focused entirely on the surrounding complexities. So if you're managing a team of developers, this should shift your focus. Stop obsessing over training programmers on basic loops and syntax, and instead invest your energy in creating a smooth, dependable path through Python's rich, yet often bewildering ecosystem. Wondering if it's even worth the hassle? The market has already spoken loud and clear. Python's popularity skyrocketed again in the 2025 Stack Overflow survey, jumping 7 percentage points compared to the previous year. Largely fueled by the surge in AI and data-related tasks. If you're a developer or shaping technology teams, growing Python skills isn't just a nice-to-have. It's now a baseline requirement to stay competitive in today's tech landscape. I've long maintained that Python became the universal language for AI, not because it boasts the absolute fastest execution speeds, but because it minimizes the gap between an idea and working code. However, this doesn't mean mastering it is a walk in the park. As a manager, your real challenge is unlocking the potential of Python by removing the obstacles that block its value from compounding in your business. Crafting a clear development roadmap. Matt Harrison's Twitter thread echoes what I often hear from developers in large organizations. Confusion around environment setups, packaging messes and dependency conflicts, import headaches, unclear concepts around data frames, and fuzzy lines between quick prototypes and production-grade systems. These problems aren't insurmountable, but tend to grow worse when companies lack clear decisions and standards. Far too many choices for starting projects, a jumble of standard tools, and too few clear-cut, high-quality examples all breed chaos. Put simply, your teams aren't struggling with Python itself. They're fumbling over decisions. When leadership ignores these issues, Python looks unreliable. You'll see builds that work on one developer's laptop, but blow up in continuous integration environments. Different teams pick different packaging systems, which then makes sharing code almost impossible. Data scientists write code that's correct, but painfully slow, because no one taught them to embrace vectorized operations up front. Developers pile on asynchronous programming without understanding when it actually boosts performance. Each problem might seem minor on its own, but together, they create a maintenance and productivity tax paid every development sprint. The solution isn't a massive, boring internal style guide nobody reads. Instead, implement what's known as a paved road or a golden path, a clearly defined, easy-to-follow way to do things right. Begin at the very start. Every Python project should kick off identically with a single command that sets up a working standardized repository. This includes a consistent project layout, an automated test framework, pre-commit hooks, and continuous integration already configured. Don't force engineers to memorize a maze of commands for installing packages or managing virtual environments. Give them an opinionated project scaffold that guarantees a green build from the first commit. This means when someone clones the template and pushes their changes, they're not just starting a project, they're inheriting your team's quality standards. This approach shaves weeks off onboarding times and ensures consistent practices across your engineering team. Next, Tackle packaging head-on. This is often where Python projects veer off course, so set clear boundaries. The community has generally agreed on a single configuration file, pyproject.toml, to handle build and metadata declarations, defined in PEP 621. Make this the organizational baseline. Whether your teams choose Poetry, PDM, or another modern package manager, your leadership role is to pick one and bake that choice into your project templates and CI setup. This makes any deviation noticeable and rare. Modern packaging tools are getting robust and fast, but you only benefit if you quit treating packaging like a free-for-all. Third, develop consistent standards for imports and project layouts. These problems are more subtle, but can cause frustrating bugs. Modules importing differently in development versus production, or packages unintentionally shadowing each other along the system path. Don't rely on tribal knowledge or guesswork. Embed a simple, uniform structure into your templates and enforce it in code reviews. The goal isn't to innovate wildly, but to be predictably straightforward, which is a huge win in production environments. Finally, automate quality as much as possible. Python's easy learning curve is a double-edged sword. While it invites everyone to start coding, it also means untested, prototype-level code can slip into production. Integrate linting, formatting, type checks, and automated tests into your pave road. Configure your CI pipeline to run these checks automatically and block merges if tests fail. This way, you ship better, more reliable Python code with minimal overhead. Teach foundational concepts, not just syntax. It's rarely the language features themselves that slow developers down. It's the absence of solid Menti models. Investing in training that bridges Python's design with intuitive developer understanding pays the biggest dividends. Focus on 3 core areas. First, the data model. Instead of overwhelming developers with a flood of special methods, often called dunder methods like init, iter, enter, exit, teach what purpose these serve in making Python code elegant and maintainable. For example, explain how defining iter makes your custom types iterable in loops, how enter and exit support safe resource management with the with keyword, and how descriptors enable property-based attribute access. These aren't just clever language tricks. They're essential for writing Python code that feels idiomatic and lets teammates quickly understand what's going on. This is also a cautionary note against letting junior developers blindly trust AI-generated code without grasping these principles, which often leads to good vibes but bad code. Second, the data frame mindset. Many newcomers used to explicit, step-by-step programming loops tend to write row-by-row operations on data frames, which works but is terribly inefficient. Instead, teach them to think in columns. Data frame operations are designed to be vectorized, working on whole columns or sets of columns at once, which is dramatically faster. Start with small real data sets and have your team practice chaining functions applied to columns, building habits that pay off later when working with scalable tools like pandas, Polars, DuckDB, or Apache Spark. This early mental shift saves you from costly relearning down the road. Third, concurrency strategies. The Global Interpreter Lock, GIL.